Welcome to Lesson 26, Learn C Programming on the Raspberry Pi. Okay, we're going to continue on talking about characters from our last lesson. So let's first get on to the Pi. Made a couple of changes since last day, which I want to tell you about. The first thing is that I have installed some extra fonts. So let me just do the history command here. Grep apt-get. So you can see the last ones I did were these ones here. So I did, let me just clear that out. Sudo apt-get install fonts minus Linux libertine or libertine. Not sure how you pronounce that. If I try it now, you'll see, I think you'll say it's already done. Okay. So if I start up Genie in the background, we'll just continue on what we were doing last day. And you can see what we did last day was we just had a small program here that first we moved the cursor to line 10, column 30. So we did this escape sequence, square bracket, 10 semicolon 30H. And that would position the cursor to line 10, column 30. Keep in mind that the top left-hand corner is line 1, column 1. Then the next printf is we printed the word default, and then we hit the escape sequence to change the color to light green. We printed out the word light green, and then we changed the escape sequence to change the color to red. We printed out the word red, and then we did the escape sequence, escape square bracket 0M, to put things back to normal. So let's just go and run this guy now. Build. I'll just do another build anyway, just in case. And now I will execute. And you can see that it does come out on line 10, column 30. In fact, this D here, this D starts on line 10, down from the top, and column 30 from the left hand side. So you can see the word default comes out in regular type, and then light green comes out in light green, and red comes out in red. So we can change colors, we can position the cursor, but I've added in that new font. I just want to show you, if you've added in the font, I go to edit preferences, and I go, it's set right now to monospace 18. You can set it to whatever you want, but let me open this guy up a bit so we can see it. I want to use this Linux, I'm not even sure how to pronounce that, Biolinum, like aluminum, I guess, Biolinum, keyboard O. So you see what it looks like. It looks like keyboard characters. So if I switch to that, OK, and I say OK, you can see what happened here. It switched to these little. The reason I wanted to use these is that they're nice and square. Normally characters are taller than they are wider, just because you have more pixels going in one direction than the other direction. But here you end up with characters that are nice and square. So we will use these guys for our experimentation today. But before we get on to that, I want to talk a little bit about Unicode. Just to review quickly, here's the ASCII table again. And you see all of the ASCII characters. There's about 256 of them because it's 8 bits. And in 8 bits you can get 256 different possible patterns, including zero pattern. So we talked the other day about A as being decimal 65 or hexadecimal 41 or octal 101. Okay, so but the ASCII table has limitations, and the limitation is that it's only 8 bits, so we can only get in English type letters. But the real world is not that way. The real world has hundreds, thousands of different kinds of character symbols, and we want to be able to work with any or all of them. Well, how do we do that? Well, we use Unicode. So let me bring up my browser here, and I'll do a quick search here. First we'll do a search for what is UTF-8, and we have a little definition here of UTF-8. First of all, UTF stands for Unicode Transformation Format. Okay. And the 8 means it uses 8-bit blocks to represent a character. Remember, in ASCII, we only use one 8-bit block. So we can have a maximum of 256 characters. In UTF-8, we can have up to 4 blocks. So 4 times 8 are 32. So we can have up to 32 bits represented. This gives us a possibility for literally millions of different characters. Okay. Now you'll also notice there's a link here, UTF-8 test page. If you click on the UTF-8 test page, it will go and show you single byte characters. So you look at these are all hexadecimal numbers. So a space, for example, is hexadecimal 20. A space is hexadecimal 20. An exclamation mark is hexadecimal 20 plus 1, 21. So for example, the ampersand is hexadecimal 26. Okay? So these are just single byte characters. And then of course we have multi-byte characters are more than one byte. But what you'll notice here is that all of these different tables, these Unicode tables for like Greek or Cyrillic, Hebrew, Armenian, Arabic, lots of different languages, human languages. Not only human languages, but we also have, for example, just different symbols. Let me show you some of the symbols we have here. Like currency symbols, for example, world currency symbols. So, for example, where's the euro? The euro should be on here somewhere. I'm not sure. I guess, is that the euro? Yes. So the euro is actually 20A0. So it would be 20 AC. 20 AC. And if we click on it, it gives you the details. It's 20 AC. This is the hexadecimal number. They put a U in front. It's Unicode. So that's the symbol. Okay. But what you'll notice here when you look at these guys, this Unicode is really a table of tables, because each one of these is a table. So just think about it for a second. Unicode is a table of tables. It makes sense because we can grow it and we can extend it. let me go down further. The ones we're going to be playing today, we have, for example, box drawing symbols for drawing boxes on the screen, and they have all of their character codes. Or block elements to put blocks on the screen. What I'm interested in today is this table called miscellaneous symbols. They're from hex 2600 to 26FF. And if you look at these miscellaneous symbols, there's lots of interesting symbols here. The ones I'm interested in are the chess pieces. The king, white queen, white castle or rook, white bishop, white knight or horse, white pawn, black king, black queen, black rook or castle, black bishop, black knight or horse, black pawn. So I'm interested in these guys here. So let me just set that aside for a second here, and we'll start up we'll start up Genie here on the Pi. If I can get it going. Here we go. So the last day we did this little program, and I just demonstrated how it works. Let's make a new program now to see if we can print out this white king. Because remember, this is now 2654. So it's 2 bytes. The character is 2 bytes long. It's not part of the ASCII table, it's part of the Unicode table. In fact, the ASCII table is part of the Unicode table. Okay, so let's start a new program here. And number sign inclu include, okay, stdio.h. I'm going to include also another header file that we haven't used before, locale.h, and I'll explain that a bit once we get to it. And I'll put, we haven't talked about unsigned short yet, but we will. So I'll define our white king here, WK, as 0x, and what was the number again? It was 2654. 2654, the hexadecimal number. Let me just save this guy here so I get some color into it. Save as, and I'll go into lesson 26, and I'll just call this guy, let's say I call it unsigned short, short.c, an example of using unsigned short. Okay. Remember, what an integer is basically is 4 bytes. A short is 16 bits or 2 bytes. So this white king here fits exactly into an unsigned short. That's the 26 here is the first byte, and 54 is the second. Let me see if I can, my highlighting is not too good. Let me change my color scheme. What do I have it now? Do I have it, oh, dark fruit salad? And where's that? Oblivion. I like that Oblivion 2. Okay, close. So a short is 2 bytes. Unsigned means that it can only have positive numbers. Okay, so normally we say we can have a number -1 and +1, -2 and +2, but in an unsigned number you can only have positive numbers. That's good enough for now. So the first byte has like 26 and the second byte here has 54. Okay. Now the next thing we're going to do, we are going to set our locale. I'll explain that in a minute. C type, and we'll just set it to default. And then what I'll do is I'll just print a command to change the colors to a red, which will be \E square bracket 31M. So that sends the ANSI code to change the color of the font to red. And now what I'll do is I'll print out the white king. And it's a character, so I can use %C. Actually it's a number, but I want to print it as a character. Comma white king, like that. And then I'll change the font back. I'll change the font back to, let's see, escape character, square bracket, 39M. And then I'll do a new line, just to round that off. And then RETURN 0, bang, and we're done. So this program is almost correct, but let me explain a few things first. I'll save it. Let me go back here, and I'll just type in locale. Locale. Remember, this is a Raspberry Pi, comes from Great Britain, so the default locale is Great Britain. Locale is basically configuration files that tell the operating system what letters we're using, what alphabet we're using, how to specify your time location, based on Greenwich Mean Time, what currency you use or how you use different currencies, where the commas go, where the periods go. Paper sizes, I guess that's like A4, A8 size. I'm not sure. In Europe they use these weird sizes. Here we just say letter size or legal size. Telephone numbers in Canada are 416 or area code plus the 7-digit numbers, so we have 10-digit numbers. I guess in Europe they're different. Measurements in Canada we use metric. Okay, in the US it would be I guess they would use imperial units or British type units. Let me just open up a terminal here on my Linux machine, and I'll type in LOCA like locale, and you can see that I have my Linux machine is set to Canadian locale. Everything is CA. Okay, but we're working on the Pi. We can leave it. There is a tool on the Pi where you can change the locale if you want. I think it's called Raspberry Config or something like that. Okay, so if we want it in Bash, -E, let me print out this this king here, white king. So we'll first print out this red. I'll first print out red. Then I want to print out my white king, and I'll print it out as I think I can just /U Unicode 2654. Let me get this guy out of the way here. Unicode 2654, and then I want to do this other one like that. And let's see if we get a red king on here. Well, lo and behold, there it is. You can see it. It's not at all that large, but you can definitely see it. If you wanted to have a black king, the black king is 265A. So let's change that to a black king 265 and an A, and we have a black king. I should have left maybe a space after that. So I think I'm getting it chopped off somehow, a little bit chopped off. Put a space there. There you go. A nice king. Okay. So we can do that with bash. Now let's try it. We'll just compile this guy. Let's see. Save it. Build. Like that. And it compiled successfully. And then we can execute. And remember, when we execute, we're using this other crazy font. Oh, but it's coming out as a T. See, it's not a king. It's coming out as a T. So why is it coming out as a T? Well, there's a reason for that, because we're printing out one character here. And by default, characters are 8 bits. So we're only printing out half of this WK. So we have to put in here the letter L to say a long character. We don't want to print a regular character. We want to print a long character, which is like a 2-byte character. So now if I save it, build it again, and execute it, and you can now see that I have here that white king comes out nice and square like that. Okay, well, what I want to do now is let's change the font size here. So I'll go to preferences, and I'll change the font size here to maybe 48 points. Make it nice and large. 48 points, so it'll be nice and large. I'll say OK, OK, and now I have a nice king here. Looks really cool. But my terminal is way too big, so let me make my terminal smaller. I got too many columns, so I'll set the columns to well, where do we set the columns? Well, not in here. I guess we can't set advanced. No, we don't. So all we can do here on this LX terminal is I guess we can just go, wow, it's huge terminal. Let me just grab this corner here and just try to collapse it a lot. So if I can make it smaller, we're getting there. And it's still too large that way. Am I making it smaller here? Yes, there we go. So that's about a good size like that. Okay, so let's try this now. I'll close this guy, and I'll put in the white king. I'll change it to a red king, which is 265 capital A. Save it, build it, and execute. And I hope my terminal stays the same size as it did before. No, it doesn't really. It goes back to its large size. Oops. Well, that's not bad. I don't know how I did that, but it made it smaller anyway. So that's our nice king, but a good size for that. Okay, so we sort of know now how we can position these players onto the screen. And let me now open up a program that I wrote earlier. File, open, and I put it in. I think I just put it in stuff. I just called that excuse me, I called that program Chess1, and this is it. Now it's a little bit long, It's about 200 lines of code. But let me just show you what you can do with it, then we'll go over the code a little bit to get familiar with it. Let's first see if I can build it. Well, I'll first save it. I'll save it as, I want to save it inside the lessons directory in the 26 directory. Save it. And now I'll say build. Compilation failed. Boom. Place the piece. Place the piece. So that's really on place the piece. So let me find that. Place pieces on board. Place piece on board. Maybe I have to do a search here for place the piece. So what's the next one here? Place the piece. Let me try it again. Place piece on board. Place the piece. Hold. Have it here. I only have it in two places. I guess I must have renamed it to something else. Move the piece. So it should be called move the piece. So let me change that here. Move the piece. And also move the piece. Move the piece. So let's see if this thing compiles. Build. And it says compilation finished successfully. Okay, so I think we're on the right track now. Let's try to run this guy. Build and execute. See how it works out. Okay, so there we have our chessboard. Now how to make this guy a little smaller, but anyway, you can see the pieces are laid out. So if I want to make a move now, it's asking me for a move. Let's say I want to move E2 to E4. I could say E2, E4, and I make a move. And then the black could respond with the knight. Let's say the knight on G8 moves to F6. So G8, F6. And the knight moves out. Okay. So I'm not doing any validation. In other words, you could move any piece anywhere. let's say I could move this queen here, which is D1, and I could move the queen over to right in here, which is G8, and it would just move the queen way over there. So I'm not really checking any if they're legal moves or not. I just wanted to show you that you can actually get this display working with Unicode characters. And I think it looks pretty nice too. You could make it bigger. You could make the font a little bit bigger. I'm not sure. If I went to preferences, right now the size is 48. If I want to make it just a slightly bigger, maybe 56. Okay. And you can see now it's getting to be a size where you can actually see it properly. Okay. So going back to this guy, if I make it full blown, let's take just a minute or so. I don't want to go into the whole thing, but basically what I do is I have this while loop here, where what I do is I move the cursor to 1111 or line 11, column 1, and I say enter your move, and I scan in the move. But you notice before I get into the while loop, I display the chessboard, so I have a function for that, and I play the pieces on the board. I place the pieces on the board. So these two lines just give me the original setup. So if you look, display chessboard and place pieces on the board, place pieces on the board is right here. It puts all the pieces on the board, the black and the white pieces. And display chessboard just displays a blank chessboard with the letters A through H and the numbers 1 through 8 on the board. Okay. And then this loop I just go through every time I read something in, and I end up updating. I have an array here which I use to keep track of the pieces. So every time I make a move on the screen, I have to update this local array. Okay. And then I just go and set the square color and move the piece. And I just go in this loop until I get like an invalid row and column number. And so there's all my pieces, all unsigned short. There's all of the white pieces, and these are all the black pieces in Unicode. I also have some things here for, this defines a white square. That's the color of a white square, and that's the color of a black square. Yeah, I know it looks kind of long. I'm thinking of, I'm not sure, I might have to upload all this stuff onto GitHub. Once I have the time, I'll upload everything to GitHub, and then you'll be able to see all the lessons there. Okay. In the meantime, I guess for homework, use Bash to try to print out some Unicode characters, and also write a C program to try to print out some Unicode characters. So until next time, have a good day, and we'll see you later for lesson 27.